Disclaimer: the information in this podcast is for educational purposes only and is not medical advice. Always consult a qualified healthcare professional before starting or changing any supplement, peptide, or treatment. Today we are exploring MGF, or mechano growth factor, a fascinating peptide that plays an important role in muscle growth, repair, and regeneration. MGF is a splice variant of IGF-1, or insulin-like growth factor 1, and it is naturally released in the body in response to mechanical stress or damage, such as intense exercise, resistance training, or injury. This peptide has been the subject of research for its potential to support recovery, muscle hypertrophy, and even tissue regeneration. Let's dive deeper into what makes MGF unique and why it has gained so much interest in performance, health, and longevity discussions. To start, MGF is part of the IGF-1 gene family, but it is a unique isoform. When muscle fibers experience micro-damage from heavy lifting or stress, the IGF-1 gene expresses different splice variants, one of which is MGF. Unlike other forms of IGF-1 that are more systemic, MGF acts locally in the muscle tissue where the damage occurred. This local action is key because it allows MGF to stimulate muscle satellite cells. Satellite cells are like reserve cells that wait for the signal to repair and rebuild muscle fibers. Once activated by MGF, these cells proliferate, fuse with damaged fibers, and support growth and regeneration. One of the most interesting aspects of MGF is how quickly it is released after exercise. Studies suggest that within hours of muscle stress, MGF levels rise locally to begin the repair process. This makes it a very immediate responder in the body's adaptation to training. Without this signal, recovery and hypertrophy would be slower and less efficient. That's why researchers have looked closely at MGF as a possible therapeutic or performance-enhancing compound. Let's talk about how MGF works. First, it increases the number of muscle stem cells available for repair. Second, it promotes protein synthesis, which is crucial for actual growth of muscle fibers. Third, it seems to reduce apoptosis, which is the programmed death of cells, helping to preserve existing muscle. Finally, it can have effects beyond skeletal muscle, with some research suggesting benefits for cardiac muscle and even neural tissue. When comparing MGF to IGF-1, LR3, or DS-IGF-1, which are more common in peptide discussions, the big difference lies in duration and specificity. IGF-1 LR3 has a longer half-life and more systemic effects, while MGF is short-lived and local. That means MGF might be more targeted for repair and growth after training, but it does not circulate widely or for long periods. Some researchers have explored synthetic versions of MGF, such as PEG-MGF. This is a pegylated form, which means the molecule has been attached to a polyethylene glycol chain to extend its half-life. Natural MGF breaks down quickly, limiting its use as a therapy. PEG-MGF, on the other hand, has been investigated to prolong activity and potentially enhance outcomes. This raises both excitement and caution, since altering the natural rhythm of MGF could have unpredictable effects. Let's consider potential applications. In sports and bodybuilding, MGF has been discussed for its possible role in accelerating recovery from intense workouts, supporting muscle hypertrophy, and even enhancing strength over time. For medical contexts, it has been studied for muscle wasting conditions, age-related sarcopenia, and injury recovery. There is also emerging interest in whether MGF could play a role in neurological repair, given its influence on cellular regeneration pathways. Of course, with potential comes risk. One concern is that peptides like MGF, especially in synthetic or modified forms, may stimulate unwanted growth. Since IGF pathways are linked to cell proliferation, researchers caution about possible connections to tumor growth if used improperly or in uncontrolled ways. That's why medical oversight and ongoing research are so important. Let's shift into the training connection. Imagine you go through a heavy squat session, causing micro tears in your quadriceps. Your body responds by releasing MGF locally in those muscles. This peptide activates satellite cells, which then multiply and merge into the existing fibers, leading to thicker, stronger muscle fibers over time. This is the body's natural adaptation system, and MGF is one of the unsung heroes behind the process. Without it, progress would be slower and recovery less efficient. The timing of MGF release is another fascinating element. It appears almost immediately after exercise, but its window of activity is short. This aligns with the idea that the body has a tightly regulated process for repair and growth. Artificially extending or altering that process may have benefits, but it may also disrupt natural balance. This is why more research is needed before MGF could be considered a safe and effective therapy. Let's discuss some of the scientific curiosity around PEG-MGF. By extending its half-life, researchers have tried to create a version that circulates longer and provides a more sustained effect. This may improve muscle recovery and adaptation in theory, but it may also change the localized nature of MGF. Instead of acting only in the stressed muscle tissue, PEG-MGF could have more systemic actions, and that could be a double-edged sword. It highlights how modifying peptides is never just about extending duration. It can change the entire pattern of how the body responds. Beyond muscle, MGF has shown potential for cardiac repair. Some studies suggest that after a heart attack or cardiac injury, MGF expression increases to support recovery of cardiac muscle. This hints at its broader regenerative role in the body, not just in skeletal muscle. For older populations or people with chronic illness, therapies based on MGF could someday offer new strategies for preserving muscle and tissue health. Another intriguing area is the nervous system. Early research points to MGF possibly having neuroprotective effects. This could mean applications in neurodegenerative conditions or brain injuries, though research is still in its infancy. It adds to the picture of MGF as more than just a muscle peptide. It may be a key player in tissue repair across systems. Now, let's think about longevity. As people age, levels of growth factors decline, muscle mass decreases, and recovery slows. If MGF can stimulate satellite cells and help maintain muscle integrity, it might be part of the solution for healthy aging. Of course, whether this can be harnessed safely in humans remains an open question. With any peptide, safety is paramount. Because MGF is so closely tied to cell growth and repair, the line between regeneration and uncontrolled proliferation is fine. Long-term studies are still lacking, and regulation of synthetic versions is limited. This makes clinical use and availability inconsistent across the world. Let's explore the practical side. In experimental or underground use, MGF or PEG-MGF may be delivered via subcutaneous or intramuscular injections. Dosing protocols vary widely, since there is no standardized medical guideline. Some reports suggest localized injections near trained muscles, while others explore systemic use. Again, this falls into a gray area that highlights why research is still ongoing. As with many peptides, anecdotal reports from athletes and bodybuilders describe faster recovery, increased fullness in muscles, and better growth when combining MGF with intense training and nutrition. But anecdotes are not the same as controlled trials, and individual experiences can vary. In conclusion, MGF is a remarkable example of how the body responds to stress and adapts to become stronger. As a splice variant of IGF, 1. It plays a unique and powerful role in muscle repair, satellite cell activation, and potentially broader tissue regeneration. While synthetic versions like PEG-MGF are being explored, much remains to be learned about safety, effectiveness, and long-term outcomes. Disclaimer: this content is educational and not a substitute for medical advice. Peptides like MGF are still under study, and their use outside research or medical supervision carries risks. Always consult a healthcare professional for guidance. Thanks for listening, keep learning, and stay curious.